As you can see, we were tasked with recreating the fishing game in OpenGL. So I currently have a fish and a shark object moving independently in the scene, as well as a fisherman at the very top, who, if I hit A and D on the keyboard, will move back and forth in the scene, as if this was a real game. To start, right now you can see the diffuse lighting, and if I hit 2 on the keyboard, it will switch to the my ambient lighting, and followed by, if I hit 3, specular lighting. So you can see the specular reflection itself on the top of the meshes as the light passes by. And to get into the code, so even though we don't have blur implemented, we still create a frame buffer object for the scene, as well as initializing the object down here in its own function. This is followed by initializing all the shaders, loading them before initializing them. So most importantly, the specular, ambient, and diffuse lighting that you saw earlier, all in fragment shaders. We then make materials of all the fragment shaders, as well as the vertex shaders. And to go down here, we load all the meshes, so most importantly the fisherman, the fish, the shark, and the dock. And we just create variables for all the meshes themselves. I should also note that these are loaded from OBJ files exported from Blender. If I go down here, so initializing the scene itself. Initialize the fisherman, the fish, the shark, and the dock, all in world space with XYZ coordinates, as well as giving them a rotation and a color value to orient them properly in the scene and give them a unique color so they'll stand out. In terms of updating the scene, right here we set the light position XYZ and give it a radius and rotation, so it's constantly spinning around the scene itself to affect the lighting and show off the different shaders, such as specular. If I go down here, I'm simply updating the position of the fish and the shark using if and else statements, as well as booleans, and also the fisherman's position, which will be updated using this variable here, f position, which is changed by hitting the A and D keys, which you'll see later. To go down here, so just in display callback, I simply create an auto for each of the different shader materials, so specular, diffuse, blur, all of that, and we render them we reset them into iSpace here, so the lighting calculations themselves. I used just an int mode for switching between all the different modes. This was actually gotten from Michael's tutorial, as this is the implementation he used for our first lab. So to show off, to set the shaders, I simply set the material for all objects to that shader's object, or that shader's material. So for diffuse, I just use the default one. For ambient, I use the ambient, specular, same thing. And finally, if I go down to the keyboard callback function, you can see here in the A and D keys, that's where I move my fisherman, and just the 1, 2, 3 keys are for setting diffuse, ambient, and specular in the scene.
Hello and welcome. My name is Bosco. I was given the fisherman scenario. Right now we're looking at the diffuse lighting, and let's check out how we did it. So first we normalized the light position in XYZ direction minus the viewing position, as well as the normal itself. And then later on we need to initialize all the variables that we need for the diffuse calculation, n.l, diffuse intensity, diffuse color. And so we also have to set up the output color for diffuse color, if the background is showing that it's dark. And the diffuse calculation formula is basically diffuse intensity multiplied by n dot L and diffuse color, and then we return the variable, not the variable but the result, and then add that back to the output formula right here. And then next up we have ambient lighting. This one's super easy. Basically, we just have to initialize the value for the ambient light, and then just make it equals to the ambient, and then return the result, and then add that back to the output formula. And then last, we have specular lighting, and first we have to initialize the value for specular light, and then we need to normalize the normal, and normalize the light position in XYZ direction, and then we need to initialize the reflection direction, and then as well as the v dot r, and then we calculate the calculation by using this formula right here, and then return the result, and then add that back to the output formula.